Hey, welcome to lecture 17 of CSE 4635. In this lecture, we will be talking about web services and we will be taking a look at SOAP and RESTful web services. So let's begin. So at first, let's try and understand what web service actually means. Let's take a look at this definition first. So a web service is a standardized medium to propagate communication between the client and server applications on the World Wide Web. A web service is a software module that is designed to perform a certain set of tasks. Now you will see that in this definition, I have emboldened a few keywords. So the first keyword that we will be looking at is communication. So from this, we understand that the main purpose of web service is to enable communication between clients and servers on the internet. Again, we have emboldened another word, which is software module. So from this, we understand that web service is essentially nothing more than a software module which can be developed in any language. And finally, a web service performs a certain set of tasks. So whenever a web service is called, then according to definition by its developer, the web service will be performing a certain set of tasks. Okay. So a few keywords or a few characteristics that are related to web service is as follows. A web service can be searched for over the network and can also be invoked accordingly by clients. So this is something similar to what we have seen in the last lecture about distributed object-oriented concepts, right? So similar to that, web services are located on the internet. That is, they can be searched for over the internet, and given the right address, they can be invoked by clients. When these web services are invoked, they will be able to provide the functionality to the client that invokes that web service. So suppose client A invokes the web service B. Then what will happen is the web service B will provide some service to the client A. So that's how the web service works. Now let's take a look at the working principle of web services. So in this picture, you can see that we have a client and we have a server. The server is hosting some kind of web service. Again, remember that a web service is nothing more than a software module which has, suppose, a particular set of methods that perform some kind of functions. So anyway, the client will send some request to the server, that is this server hosting the web service, and then the server will simply send a response back to the client by actually executing the methods that are present in that web service. Okay, so the client would invoke a series of web service calls via requests to a server, which would host the actual web service. So basically what we have just discussed right now. These requests that the clients make are made through what is known as remote procedure calls, or RPCs. Remote procedure calls are calls made to methods which are hosted by the relevant web service. So now you might be wondering what this actually means, what all these things actually imply when it comes to real-world applications. So, for example, Amazon provides a web service that provides prices for products sold online via Amazon.com. Now, the front end or the presentation layer that is visible to the client can be written in any language like .NET or Java, but it doesn't really matter in case of web services. Both of those applications, be it either written in .NET or Java, they will be able to access these prices by simply invoking the web service that Amazon provides. Okay. Now, you guys probably have a lot of questions regarding how exactly programs or applications that are written in different languages communicate with each other through web services. Don't worry, all those questions will be answered as we move on or as we dive deeper into this lecture. So let's take a look at the core concept of web services. Now remember, the main component of a web service is the data which is transferred between the client and the server. Now that data is usually in the format XML or JSON. Now this is where the functionality of interoperability between applications of different languages or different platforms comes in. Since the data that is being transferred between clients and servers are written in XML or JSON format, so that basically means that all kinds of clients and all kinds of servers, regardless of their platform or language, can interpret those messages, right? Since XML or JSON can be understood by all. The client and server communicate in XML or JSON, which provides a common platform for applications developed in various programming languages to talk to each other. So just what we just said right now. Now, the data that is sent between the client and the server is sent over our normal HTTP connection. Now, regardless of the kind of web services that you use, there are mainly two types: SOAP and RESTful. Now, SOAP stands for Simple Object Access Protocol, and RESTful stands for Representational State Transfer. And we will be taking a brief overview of both of these web services as well, but later on. Now, again, it doesn't really matter what kind of web service you implement, whether it is SOAP or RESTful. Both of these different kinds of web services will have some common properties or some common characteristics. So a web service will basically have a class or multiple classes that contain methods that will provide some functionality or some services to the client. Okay. Next, a web service will have its own techniques to expose the methods or services on the internet, that is on the network, and specify how exactly the clients can access them and where the clients can access them. And finally, the transfer of information that happens between the client and the server is a language and platform independent manner. So just as we discussed earlier, either XML or JSON is used to transfer the message between the client and server. So that ensures that the transfer of information is happening in a language and platform independent manner, right? So now that we understand somewhat what web services are and why they are useful, let's move on to our discussion about SOAP. So we already know that web services are basically created to facilitate the communication between client and servers that are written in different languages or that are created in different platforms, right? So to facilitate this communication, SOAP utilizes XML as the underlying medium for data exchange. Now, obviously, when we talk about XML, we know that there is really no specific set of rules that are imposed on XML. So we know that XMLs can be created for anything that we like, right? So what SOAP does is SOAP defines a set of rules or a set of specifications on the use of XML language across all programming languages for data exchange. So any application written in any language that implements the SOAP protocol needs to follow this set of specifications so that the transfer of information, that is the transfer of messages between these different language applications, can be achieved. Okay. Now, we know that XML itself is a very lightweight language, right? So since SOAP is based on XML, we can say that SOAP is also a lightweight protocol. SOAP allows distributed object systems to be implemented via web services as well. So the way this works is in an XML file, SOAP defines the type of object and the methods that are basically related to that object, and this basically allows distributed object systems to be implemented via web services as well. Finally, SOAP works on the application layer protocol HTTP, which is the default protocol used by all web applications. Now we know that HTTP resides on the application layer of our network. So since this HTTP is the default protocol that is used by all web applications across the world, SOAP works on this application layer protocol. And since SOAP works on this HTTP protocol, we can say that all web applications will by default support the SOAP protocol as well. Now let's take a look at the building blocks of SOAP. So the SOAP specification defines something known as a SOAP message, which is basically sent to the web service and the client application. Now you might be wondering what a SOAP message is. Well, whenever a client actually requests for something from the server, a SOAP message is generated. Similarly, whenever the server sends a response back to the client, it is sent in the form of a SOAP message as well. So what is a SOAP message? Request or response, a SOAP message is nothing more but an XML document that has the following components. The first element, which is the root element in the SOAP message, is the envelope element. This envelope element identifies the XML document as a SOAP message. This is the root element of the SOAP message, as I have mentioned, and it is used to encapsulate all the details in the SOAP message. Now, all the other elements that will be present inside your XML document will be encapsulated, that will be present inside your SOAP message will be encapsulated by this envelope element, okay? Also remember that this envelope element will contain some attributes that will basically define what kind of document this is. That is, this is a SOAP message and some other specifications related to SOAP message. The next element, which will be present inside the envelope element, is the header element. Now, the header element will contain different kinds of header information like authentication credentials, which can be used by the calling application. It can also be used to contain information on complex data types that you plan on using inside your SOAP message. So by default, SOAP message contains parameters or can contain parameters which could be of simple types such as strings and numbers. But if you want, you can define complex object types as well, which will be defined inside this header element. Okay. So remember, whenever a client sends any request to the server, they can send requests, they can send parameters as well with those requests, and these parameters can be in either strings or can be either primary data types like strings and numbers, or if you want to define any complex data type, that complex data type can be defined inside the header element. Okay. Similarly, whenever the server sends back a response to the client, the server can send back simple data types like strings and numbers, and at the same time it can also send complex data types like suppose whatever you want, and those complex data types will be defined inside this header element. And by looking at this header information, the client or the server will be able to basically understand what kind of data type is being sent over. Okay. So next we have the body element, and this is the element which actually contains all the actual message body. So this element contains the actual data which needs to be sent between the web service and the calling application. Okay. And finally, we have some optional fault elements. The main purpose of this fault elements is to basically store error information in case of failure to fetch any resource. So for example, as a client, you have asked the server for some kind of service. So if the server fails to provide that service, a fault message is generated which contains this fault elements, and this fault elements will basically describe the kind of error that has occurred. Now, one thing to remember about SOAP messages is that SOAP messages are normally auto-generated by the web service when it is called. So whenever a client application calls a method in the web service will automatically generate a SOAP message, will have the necessary details of the data, which will be sent from the web service to the client application. Okay. So now that you have an idea of how SOAP works, you should also have an idea of how SOAP actually offers interoperability between multiple platforms, right? Because whenever a client actually sends a request to the server, that request is essentially converted into an XML document, right? And that XML document can be read by the server, interpreted by the server, and the response that is generated by the server is also sent back in the form of an XML document. So we can understand from this that the main interaction that is happening between the client and the server is happening in an XML format. And since XML is a universally understood language, so the interoperability between multiple platforms is easily achieved. Now that we have seen how SOAP performs, let's move on to the RESTful API or RESTful services. So REST is a software architectural style that defines a set of constraints to be used for creating web services. So remember, SOAP is a protocol, but REST is a software architectural style. Web services that conform to the REST architectural style are called RESTful web services, and they provide interoperability between computer systems on the internet. So any web service that conforms to the REST architectural style are called RESTful web services. And again, they provide interoperability between computer applications that are written in different languages and for different platforms. In RESTful implementations, all kinds of information like data records, objects, and so on are regarded as resources. RESTful web services allow requesting systems to access and manipulate textual representations of web resources by using a uniform and predefined set of stateless operations. So let's try and understand what that means. Now, as a client, you might ask for any kind of information from the server, right? So suppose you are asking for a specific record on some employee information, okay? So what the server will do is the server will take this request, and based on the kind of instructions that have been written by the developer, that is based on the kinds of methods that have been defined by the developer of the server, that information is going to be sent back to the client in the form of a textual representation like JSON or XML. And the client will essentially receive this textual representation, and based on the kinds of methods that the developer has defined. RESTful web services can send information in formats like JSON, XML, etc. So essentially what we have just defined here. So the transfer of information, or the interchange of information that is happening between the client and server of RESTful web services are in JSON or XML format or some other universally accepted format. So unlike SOAP-based web services, there is no official standard for RESTful web APIs. This is because REST is an architectural style, while SOAP is a protocol, right? So REST is not a standard in itself, but RESTful implementations make use of standards like HTTP, URI, JSON, and XML. So these technologies are used whenever we actually employ the REST architectural style. Now, there are some restrictions that you need to follow for a web service to be called RESTful. So let's take a look at those restrictions or those constraints. So a RESTful web service must follow the client-server architecture. The reason we say that it must follow the client-server architecture is so that we have a clear separation of concerns between the client logic, that is, between the view logic, and the server logic or the business logic. Statelessness. So we already know what statelessness means. The state of the application must not be maintained or is not maintained in RESTful web services. Clients are responsible for passing application state to the server whenever it needs it. The constraint of storing application state on the client rests on the client rather than on the server, and this essentially makes the whole thing restless, or the whole communication stateless. Cacheability. So a lot of times you will say that a client will be asking for the same resource multiple times. Now, to reduce the number of operations, that is to reduce the number of operations on the network traffic, what happens is responses in RESTful web services must be defined as either cacheable or non-cacheable. So if a response is defined as cacheable, then a client which is asking for the same resource multiple times will essentially get a pre-fetched record or a pre-fetched resource that has been fetched at an earlier date. On the other hand, if it is defined as non-cacheable, then what happens is whenever a client asks for the resource multiple times, the same resource will be sent by the server again and again instead of having it reload from some cache. Next, we have layered system. So the concept of layered system works like this. So since we have a client-server architecture, whenever a client actually asks for something from the server, the client is completely impervious to the knowledge of whether there are any other layer between the client or the server. That is, the client does not know whether the client is actually communicating with the server or the client is communicating with some other intermediary layers. What the client is only aware of is the end result that the client receives from the server, right? So introduction of multiple layers between the client-server model should not hamper the actual end goal of the client-server communication. That is, the end goal being what the client actually receives from the server, right? So multiple layers or intermediary layers may include something like a middleware, which actually contains the business logic, and your server contains just a database, right? So something like that. Next, we have uniform interface. Now, this uniform interface constraint is fundamental in the design of any RESTful system. A uniform interface imposes the following further constraints. So the first constraint is resource identification in requests. Now, this means that individual resources are identified in requests by using unique URIs. So each resource will be identified by a unique URI that will be defined in your server. So whenever, as a developer, you are creating your web service, you will be defining a unique URI for each service that you have created. So for example, you might create a method called getEmployee, which returns the list of employees and their information back to the client. Now this getEmployee method will have a unique URI, which the client can call to actually invoke this method. Okay. Also, the resources themselves are conceptually separate from the representations that are returned to the client. So for example, the server can hold this employee records in the form of an Oracle database, right? However, whenever the server actually sends the employee records to the client, these records will be in the format like HTML or XML or JSON, right? It doesn't matter. However, the conceptual representation of these resources are different from the internal representation that is present on the server side. Okay. Next, we have resource manipulation through representation. So in this case, what happens is through representations, whenever a client holds a representation of a resource, that is, whenever a client actually holds the resource in XML or JSON or whatever format, the client will have enough information to modify or delete the resource's state. That is, the client will have enough information to actually modify the resource that it has just received. Okay. And finally, we have self-descriptive messages. So this is very self-explanatory. So whenever the server actually sends back a response to the client just by taking a look at the message or just by taking a look at the received JSON or XML document should be able to understand what kind of parser should be used to actually parse that message. So there is a special attribute called media type or application.media type or something like that, which can be used to define the kind of media that is being sent over from the server to the client. So whenever the client actually sees this attribute, the client will know which kind of parser he should invoke to actually parse that information. Now let's take a look at some of the key elements which actually define RESTful web services. So the first element is resources. So as I have mentioned earlier, in REST, every data can be considered a resource. For example, an employee information of company that is stored by a server can be considered as a resource. These resources can be accessed by specific URLs. Now, again, these URLs will be defined by the developer whenever the developer will be actually creating a method or a web service. Now, assume that the URL of the web server is www.exampleserver.com. Now, in order to access an employee record resource via REST services, one can issue the command www.exampleserver.com/employee/1. Now, again, this format of URL will be defined by the developer himself. What is happening in this URL is the client is actually looking for an employee. Suppose the client is looking for an employee with the ID 1, and for that purpose, this kind of URL can be issued. Now remember, whenever the client actually gets the response from the server, that is, whenever the client actually gets information on this employee from the server, that information will be received in the form of XML or JSON as defined by your web service. The next element in RESTful services is request verbs. So we already know that when it comes to the HTTP protocol, we have 4 main methods, right? Get, post, put, and delete. We also have some other methods, but these are the major ones. Now, RESTful web services utilize these methods to perform different kinds of functionalities as well. So, for example, whenever a client actually sends any request to the server, the client will define what kind of request method he wants to perform. So he can define either get or post or put or delete. Now, get, put, and delete are actually used to perform CRUD operations or create, read, update, delete operations on resources. Okay. On the other hand, the post method is used to send data to the server for processing. So if I had to give another example, suppose you are trying to, as a client, you are trying to get the records or read the records of certain employees from the server database. So for that purpose, you can use the get method, right? On the other hand, if you want to add another employee's information to the server's database, you can use the put method. And finally, if you were to delete any information on some specific employee from your database, from your server database, you would be using the delete method. And finally, suppose you want to do something like this. You want to send an information to the server, and you want the server to perform some kind of operation on that information and then send the response back to you. For that, you would be using something like the post. So for example, suppose you want to know the weather information of a certain city, then what you would do is you would use the post method to specify or to send information on the city on which you wish to get the weather information, and use the post method to send that information to the server, and the server will essentially return you the weather information on that city. Then we have request headers. So additional instructions can be sent by using request headers to the server. These request headers might define the type of response required or the authorization details. Request body is mainly used whenever you are actually using the post method. So in case you want or you need to send any additional parameters to the server, you use the post method to send those additional information inside the request body. And finally, we have the response body. And this is the main body of the response that is sent from the server side to the client. So in our RESTful API example here, that is in this example, if we were to query the web server via the request exampleserver.com/employee/1, the web server might return an XML document or a JSON document with all the details of the employee in the response body. And last but not the least, we have response status code, which basically you are already familiar with. It basically just says what kind of response the server has sent to the client. Now, we really haven't seen any implementation of the SOAP API, or sorry, not the API, the SOAP web services or the RESTful web services that we discussed here. We mainly looked at a very brief overview of these two kinds of services, and the implementation details of the services is actually beyond the scope of this syllabus. So yeah, if you have any question, let me know in our live class. I will see you then. Take care and stay safe.